So good morning guys. So our topic for today is all about the moving loads. So first, what is moving loads? So let's define moving loads first. So in structural dynamics, so it means gumagalaw na, kaya moving loads. This is the load that changes in time the place to which is applied. So, di ba, based from our lectures last time, so yung mga loads natin doon is static lang or hindi siya gumagalaw. So, ito, gumagalaw na tayo. So, examples of those, so yung examples ng gumagalaw na loads is vehicles that pass bridges, trains on the track, guideways, etc. So, in computational models, the load is usually applied as a simple massless force, then an oscillator, and an inertial force. So, first, let's define or let's identify what are the types of bridges. So, first is the arc bridge. Then, next is the tie-arc bridge. Then, next is the cantilever bridge. Next is the truss bridge. Then, next is the beam bridge. Then, next is the suspension bridge. And last is the cable stayed bridge. So far, yung meron lang sa Philippines is itong truss bridge, then tie-arc bridge, and beam bridge. So, parang, ito meron din tayo nito sa probinsya. So, nakalimutan ko yung name ng province na yun, pero meron tayo. Yung highest bridge in the Philippines. Then, for the suspension and cable stayed bridge, so wala pa tayo na to. Since ang suspension and cable stayed bridge is medyo mahal ang cost. So, pero dito sa Manila, so meron na tayong nilulutong project with regards to cable stayed bridge. So, ilalagay siya sa Parola Baseco sa Manila. So, ayan. So, malapit siya sa pier. So, ito, malapit na siya in construct. So, siguro by 2023 or 2022 ata yan. So, ito yung ginagawa namin ngayon, cable stayed bridge. So, ayan. So far kasi nasa conceptual design pa lang. Since, di ba, ang design, so we have feasibility studies first, then next is the conceptual design, then next is the detailed engineering design, and last is the construction. So, ngayon, nasa conceptual design pa lang yung ating cable stayed bridge. Pero meron na tayong cable stayed bridge dito sa Pilipinas, doon sa Butuan. So, ayun, makikita nyo siya doon sa Butuan. So, nakalimutan ko yung type or yung name ng bridge na yan. Pero meron na siya. Nakatayo na siya or existing na siya. Then next, so for the types of bridges superstructure, so we have pre-cast pre-tension concrete girder, cast in place post-tension pre-stress girder. Then next is the segmental concrete bridges. Then next is the composite steel eye girder bridges, composite steel box girder bridges, horizontally curved girder bridges, highway truss bridges, arc bridges, then suspension bridges, cable stayed bridges, extra dose bridges, then stress ribbon pedestrian bridges, movable bridges, floating bridges, and last is the concrete decks. So here is the example of the precast pre-tension concrete girder. So yung parts ng bridges natin, so ito, ang tawag dito is column or pier. So pier, P-I-E-R, hindi yung pier na nasa Port Manila. So iba yan. So ito ang tawag natin dito is pier. Then next, so ito ang tawag natin dito is the coping beam. So ayan, coping beam yan. So siya yung sumasalo ng ating pre-stress girders. So, ayan. So, ang tawag dito is pre-stress girder. So, we have type 1 up to type 5. So, ayan. Then, next. So, saan pa ba? So, ang tawag naman dito, so, yung mga rebar na to, so, binubuhusan din ng konkreto. Ayan. So, ang tawag naman dyan is the diaphragm. So, para maging rigid or, I mean, maging stiff yung ating concrete girders. So, ano siya, para hindi siya mag-sway ng mag-sway. Then next, so for the post-tension pre-stress concrete girder, so ang difference pala ng precast and post-tension, so yung precast, so ginawa na siya sa pabrika. So ito, i-deliver na lang siya ng mga truck. Then saan siya ipapatong. So yung post-tension kasi, doon na siya tinetension. So doon na siya binabatak sa site. So, ito, nakabatak na siya sa pabrika pa lang, then ipapatong na lang. Then, ito, binabatak na siya dito sa side. So, ayan. So, it means nakukuha niya na yung kanyang jacking force and inaantay na lang yung kanyang curing base. Then, next is for the segmental concrete bridges. So, segmental concrete bridges, so ito example nun. So, ito, kinaabit na lang yan, dire-diretso. Wala siyang support or wala siyang pier or column doon sa gitna. So, ayan. So, ito is a box girder. So, ang tawag dito is box girder. Then, next is the composite steel eye girder bridges. So, ito. So, made of steel naman yan. So, ito yung ating composite steel eye girder bridges. Then, composite steel box girder bridges. So, ito naman yung example of composite steel box girder bridges. So, ito yung ating mga pier. Then, ito yung ating abutment. So, yung abutment kasi usually nasa, ano na siya, start and beginning of the bridges. So, doon naaabit yung approach slab and yung deck slab. Then, horizontally curved bridges. So, here is the example of the horizontally curved bridges. Ayan. So, kapag kailangan natin ng radius of the curve for that specific bridge. Then, highway truss bridges. So, ito, madami tayo na ito sa malapit sa TIP or malapit sa Malacanang, yung Ayala Bridge. So, this one good example of a truss bridge. Then, arc bridges. So, ayan. So, ito yung example of an arc bridge. Then, sunod, suspension bridge. So, suspension bridge, most likely sa mga first world country lang nakikita dahil medyo mahaling cost. And, ginagamit lang ang suspension bridge kapag medyo malayo yung distance between island or distance between land. So, ayan. Then, cable stayed bridges. So, ayan. So, we all know that yung steel or cable is malakas sa tension. So, kaya ang bumubuhat sa kanya is itong mga kable. Ayan. Then, stress ribbon bridge. So, here is the example of a stress ribbon bridge. Then, movable bridges. Then, next is the floating bridges. So, ayan. Then, next, so, for the substructure of bridge. So, for the substructure, since di ba kanina, so, diniscuss natin yung superstructure. So, may superstructure is lahat ng nasa taas. So, ano ba yung mga nasa taas na yun? So, check natin ulit dito. So, for the superstructure, so usually, so yung mga nasa taas is itong railings, parapet, sidewalk, deck slab, then itong girder, and yung ating coping beam. So, ayan. Then, lahat na naman nasa baba, which is sumusupport doon sa ating bridge. So, lahat ng nasa baba is ito. So, itong coping. So, dapat pala yung coping natin is nasa substructure. Wala pala siya sa superstructure. So, kamali ako doon. So, ito. So, coping beam. Then, itong pier, which is the olum. Then, sunod, itong pile cap. And ito is the piles. So, ayan. So, ito yung nakabaon sa pinakamatigas na part ng lupa. So, ayan. Yung ating piles. Then, ito yung kanyang pile cap. Then next, so punta na tayo sa moving load. So for the principles of moving loads. So from the previous section, we see that the maximum moment occurs at a point of zero shear. So, di ba, na-discuss na natin kung nasaan yung maximum or kung nasaan yung zero shear. So nandoon yung ating maximum moment. So for beams loaded with concentrated loads, the point of zero shear usually occurs under a concentrated load and so the maximum moment. Ayan, pa-take note na lang yun. So, lagi yun, yung zero shear, nandoon yung ating maximum moment. So, beams and girders, such as in a bridge or an overhead crane. So, yung overhead crane, so moving loads din yan. Since, di ba, yung crane natin is gumagalaw. Moving concentrated loads, which are at fixed distance with each other, the problem here is to determine the moment under each load when each load is in a position to cause a maximum moment. So, the largest value of this moment governs the design of beams. So, under moving loads, we have single moving load. So, ano ba yung mga loads na yun? So, yung mga loads na yun is yung axle nung sasakyan. So, ayan. So, for a single moving load, the maximum moment occurs when the load is at the midspan. And the maximum shear occurs when the load is very near the support. So, usually assumed to lie over the support. So, ayan daw. So, position for maximum shear. So, lagi daw siyang malapit sa support, and position for maximum moment, palagi siyang nasa middle. So, ayan. So, formula for moment maximum is equivalent to PL divided by 4, and formula for shear maximum is equivalent to P. So, ayan is for single moving load. Then next, so for two moving loads, the maximum shear occurs at the reaction when the larger load is over at the support. So, it means daw, so yung gulong or yung axle ng ating malaking load, so ilalagay natin siya sa support. So, the maximum moment is given by M max is equivalent to P times L minus PSD squared divided by 4PL, where P is the load and L is the length of the beam and D is the distance between the axle or distance down between ng dalawang gulong. Where P is the smaller load, PB is the bigger load, and P is the total load, P equivalent to PS plus PB. So, ito is for two moving loads. So, what if naman kung meron tayong mga truck or yung mas madaming gulong? So, 3 or more moving loads. In general, the bending moment under a particular load is a maximum when the center of the beam is midway between that load and the resultant of all the loads then on the span. So, with this rule, we compute the maximum moment under each load and use the biggest of the moments for the design. So, usually, the biggest of this moment occurs under the biggest load. So, ayan. Then, the maximum shear occurs at the reaction where the resultant load is nearest. Usually, it happens if the biggest load is over the support and as many as possible of the remaining loads are still on the span. So, in determining the largest moment and shear, it is sometimes necessary to check the condition when the bigger loads are on span and the rest of the smaller loads are outside. So, itong 3 or more moving loads. So, ang sabi, so the bending moment under a particular load is maximum when the center of the beam is midway between that load. So, it means kukunin muna natin yung ating resultant, then yung distance between the axle. So, ayan. Then, saan natin siya isosolve or saan natin isosolve yung ating maximum moment. So, try na lang natin sa problem para mas maintindihan natin kung paano determine yung maximum shear and maximum moment for single, 2, and 3 or more moving loads. So, ayan. So, yes, start na tayo sa problem solving.